Here we go. Section 8.15. So sorry.
Well, I apologize. It's not you guys.
Here we go. Number 12, negative 23 centimeters. Displacement, that's all you needed. Number 14, 11, 16, negative 8. Depending at what position you were solving. Number 16, at t equals c, because you're looking for the steepest upward slope. Those are kind of application here. I like it. Number 22, final answer is 93.6. Yes, you were allowed to use a calculator. Calculatrice, calculadora. It would have been a great mental exercise to see if you're doing okay with your u primes if you had multiplied by 12 over pi, but ultimately it was a decimal answer. I know. Just don't forget your kilowatt hours, your units. My ones that like to be sloppy. Or I should say incomplete. Sloppy doesn't totally apply in the category. Number 26. Woo! Did you guys get 2,108.5? Did you go all the way? Gallons? Because what the integral solved for was not your final answer in the sense of the amount of the water in the tank at midnight. Because you had water that started, you had water that was added, and then you had water that was taken out. Oh, you had to put it all together. That was one of those fun problems like we were trying to allude to yesterday as far as how they could make it tricky. Oh, and that's the last one. Lo siento. Okay, what do you guys want to talk about? Anything? 25? Sorry, AJ, what is the other one? 19? Anything else besides 19 and 25? We're good? Oh, sorry, I am totally in the wrong section right now. Do you guys feel accomplished when you turn to homework and you have to turn to chapter 8? Or is that just me? Yeah, because we've gotten so far. All my other classes, it's like, just flipping like 2 chapters. You guys, it's like, boom. Or like last year in calculus, didn't we only get to like chapter 3 or chapter 4? Whatever it is. Oh, review integration by parts. Come on, we had some fun. All right. Here we go. Number 19, let's start there. Oh, he's a fun one. Look, he has a graph. A geometry graph. Why am I saying a geometry graph? It should be obvious. I got lines, right? Lines and only lines. I mean shapes. Okay, I get it, but there are no curves. Directions. The graph of the velocity is given. Particle starts at a position of 2 when t is 0. Hey, where's the 2 in my velocity graph? The initial position, where is it? It doesn't show because velocity cannot show me initial position in any way, shape, or form. All the velocity graph can show me is the rate starting at 0, how fast it was going starting at 0, and how far it went after 0. It cannot tell me where it started from. I have to be given that initial condition separately, which they told me in the directions. Find where the particle is at the end and find the total distance traveled. All right. Starts at 2, yeah? Sweet. So if it starts at 2, where is it at the end? What is... Hello? Good morning. Wake up. Oh my goodness, you guys are cute. My smartboard is not cute. Oh, hi, arrows. Okay. I'm trying to find x of 7 because isn't after 7 seconds the end of this trip? Okay, well what happened? After it started. Where is it? It says where it is at the end of the trip, right? It started 2 miles away from something. Where did you end? How do I not estimate, but solve exactly the integral? Take the area. So, all these areas, if I were being lazy, I would do things like nth at 0, so why even stress about it? However, there is this question coming called total distance traveled. Do I need to know who these guys are? Yeah, because everything turns into an absolute value. I just care about how far, not, oh, that was left and that was right. Okay, so let's find them just so that we have them. It's 1/2 base, which is 1, times height, which is 2, which is going to end up being just a 1. I mean, yeah, he's a negative, but that's an area of 1, an area of 1. I'm kind of lazy, so I'm going to do the rectangle off the trapezoid because who wants to do that? 1 and 2, that's a 2. I have 2 times 2 would be 4, and half of that, that's 2. Then I have this little dude who is 2 and 1, so that'd be 1, right? Now what's the total? I shouldn't say the word total. What's the net change? What's the displacement? Well, -1, +1, 4 minus 1 is... Struggle, but does that make sense why? It's going to be 1 minus 1, and then 4 minus 1 is 3. So it moved overall displacement, if you're in physics, displacement different than total distance, right? It's 5. But how do you do total distance? Well, we say, well, total distance is he went 1, that's 2 and 4 and 6 and 7. He went 7 altogether. That's how his speedometer ticked off. Sound good? Number, sorry, Janelle, 23? 25. It's on the next page. And he's a little more fun. Actually, it's pretty similar, though. Because what kind of graph did 25 get you as you guys look at your directions and problems that you're writing down? Shapes. Are we still using that? Okay, linear portions of a graph. I get it. There are shapes. I know, geometry. Getting on to a ride. Oh, wow, that guy's right. Why did I get right? Because he's not on. Okay. Just wait. There you go. People join. Thank you very much. Doesn't usually work that well. People join the line for a particular amusement park ride. Blah, 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 blah. There's rate. Rate. Okay, like a velocity. Density is also a rate, but okay. There are 500 people waiting in line at noon. Who is this? An initial condition. How could you have made things interesting yesterday in that problem that we were doing? Have people already in the line. Okay, 500 people waiting in line at noon. So the situation is starting at noon. People are already there waiting. If the ride can take 1,500 people per hour, the ride can take. That means taking people out of the line, right? Okay, so people are sitting, standing, whatever they're doing, in line. And then the ride is saying, hey, come on, get on the ride and get out of the line. Okay, cool. So this is people in the line, and then we have people adding to the line, and then we have people being subtracted from the line as they get on the ride. How many people are waiting in line at 5 p.m.? Someone give me not only a how you thought to solve it, but also a justification as to why. Who can walk me through the solution? Patricia, go.
I drew a line on the 1500 line, and then I just made shapes and took the area of all the shapes. And then I added them together.
Can I be super AP-ish and snazzy and call it L? So people leaving, and then he's people joining. I know it's taking a while, but go ahead. What do you mean you found shapes? What shapes do you find?
Like, they're all triangles, but I just took the area of each of them.
Oh, so you were doing like area between. Why were you thinking of going between them?
Because it said it could take 1,500 people. So at 1,500, like all those people were already together.
And what made this problem a little bit easier than some AP problems is at noon, the ride started taking people. It wasn't one of those that the line was backing up and no one was going on the ride because it was broken down. It was, no, people are going on the ride and adding the line and going on the ride and adding the line. Which was different than the banana problem on the AP, because the banana problem said, ooh, the store opens and people start taking the bananas and the person to restock doesn't come on for another 2 hours. There would have been an interval gap. So it's okay that Patricia started drawing this at the very beginning, because both of these things were happening from noon on. Does that make sense? So, and you're doing area because there's an integral, yeah? And your bounds are noon, which I'm guessing is a 0, yeah? But after you found each of these areas, it is in essence subtracting the 2 and trying to figure out what was left over. What else did you have to consider to think about how many people are actually in the line? And then, wait a minute, guys, could I use R or L if I was trying to write an expression for an AP FRQ? You have to label it your own, something else. How about something like the number of people in line? Does that make sense? Can't be R, that's the rate at which they're coming into line. You can't use L, that's what I call them going onto the ride, leaving the line. So N, sure, why not? Now, what's the struggle if I keep on using the area between as my terminology? Patricia just said she found little shapes. I said area between. Am I right?
Did you find like the total area and then just subtract by the rate, because the rate's constant, and that'd be easier.
You could. You could do total area, total area, total area, and then subtract all of this, which is another way of solving. What Patricia is doing is this, and you're doing this, and then that. Does that make sense? Both ways technically work, but my question was, can I use total area between, or can I use area between at all? Why or why not? The thingy goes under.
So you have to do it. It's not area between, because you need to subtract things.
What Joe is saying is at this point, there are more people going onto the ride than there are adding to the line. And so I need that difference, literally subtraction, to be seen and to be evident. If I use area between, what am I technically saying? Absolute value, total distance traveled. So my area between description of Patricia's way of solving was incorrect. Why am I saying that? Because if you actually wrote an FRQ, oh, the area between, there goes your point for, hey, you made a mistake, even if your answer was right. Anyway, coming back, beware that word between. Kevin's way is right and Patricia's way is right, in a sense of, as long as Patricia made this a positive, and that a negative, aka having this go in the red, and then add it to 500, it would have worked out. And then, actually Kevin, if Kevin had done the full underneath the R curve and then the full underneath the 1500 curve, which was just a rectangle, and then subtracted the 2, you would have also been fine. But as far as being lazy, I wouldn't have liked doing trapezoids or doing, I guess rectangles wouldn't have been that bad, because that would have canceled away. This would have had a little extra, I don't know, which way is actually technically simpler. But find those areas, and then you end up, this is 8,000, I'm guessing, are these two? Added together, and then the 7,500 is that one getting to the 1,000? Does that look about right? Yeah. Because you have 1/2 of your 2 times 500, so 1/2.
Just 500.
Oh yeah, this is doing it Kevin's way. My bad. Doing it Patricia's way would have just had your adding 500 and then adding and subtracting an equal amount, so it would have just canceled away. Anyway, 1,000 people. Janelle, is that good? It's one of those classic in-out things where the times are equal, which makes it even easier than the AP would have made it. With that, cool kids, unless there's anything else additional before I shut the book and close the webcam before it freezes up my computer more, let's go back to section 8.2. Let's turn that off. Let's close you down. And let's go start playing. Dean and Gavin, I apologize. We had this interesting, I don't know if it was interesting to the kids. It was interesting to me knowing that the shell method is coming, talking about the representative rectangles and how a quick reminder, these ideas and whether or not they actually work Oh, he's not in front. That's so sad. That would have been so cool. Hold on, pause. Let's get him, and let's get him. Let's bring their order to be in front. There we go. Anyway, whether or not it could be a representative rectangle for this area tells me whether or not I can use dy and have everything in terms of y, and whether this one can be a representative rectangle for the area tells me whether or not I can do dx. That's something important for us to keep in mind. This whole areas and volumes chapter. Okay, so absolute value. We're doing area between, the word between. But when you use the word between, like if you ever use an it in an FRQ. I have teachers at the conference that I went to that literally say if their kids ever use the word it, they automatically take off points. I was like, whew, that's rough. But understandable. Anyway, there are certain things we have to watch out for, especially in our FRQ justifications and explanations, like positive versus increasing and the difference. Anyway, absolute value is necessary for between, thinking only of the positive, like the total distance traveled, but as soon as we have absolute value, we have to remember to split it up when necessary. True?
What's that say? That says give it into
Intersections. We're stuck back there. Okay. Defined, if the bounds are defined for us, if they give us the intersections. For the bounds, this is if you don't even know the bounds yet. Either they give you, hey, between here and here. Sometimes it's given for you. Or sometimes you say the area between, so then you need to go looking by setting the two functions equal to each other. So it was a reminder of, if it's given, sweet, use it, but watch out, absolute value. If you're finding by hand, think about your intersections, which kind of help you about the absolute value too, because you're setting them equal. And when you're setting them equal, you're finding when the subtraction is 0. And this one says, hey, that orientation is super important unless. Oh, yeah, I can. Just be careful. Quick reminder, if you're using him, gotta split up at those intersections. Oh, that's no fun. It's all for you. See, I wasn't minding all the rest of it, but that, no. You guys can't just look at a problem already solved. Some of you could, but it's not as much fun. Sometimes I accidentally don't make a new copy every year, so that gets all messed up. Come on. Come on. All right, ready, set, play. These ones are both bounds or defined. Oh, I gave you a picture? That's so fun. I think I can zoom. Top of your head, the clock is ticking. You have like 2 minutes left and 3 multiple choice questions. What would you try to do real fast? Really? Interesting. I think I, as a little calculus robot, would just be like, I don't know, it's a y, and it's a 3y, I'm just going to go for it. That's what I would have done if I was desperate on time without even thinking about the problem. Anybody else with me on that? So then we would have gotten our 3y squared all over 2, 0 to 3. Hey, that's a 0. Nice, plugging in a 3, that's a 27. I see an answer, I'm just going for it, right? And pause, are we right? Geometry, Lainey, your turn. Because I was going too fast, because I was desperate, and I was just not paying attention. Hopefully 27 halves would not be there. trig, just plug it and chug it and hoping that we're right. Lainey, geometry. What do you mean?
Alright, so it's a triangle.
Why? Which triangle?
Makes a right triangle.
Going what direction?
Going
Down to the x or over to the y?
over to the y.
Got it. And I have y is 0. I have y is 2. And isn't this the same thing as y equals 1/3 x for those of you guys that are like, why did she draw a line? Because it is. mx plus b, f1 over b.
Yeah, so since the y is 0 to y to 2, I plugged in the 2 to the x equals 3y to get x equals 6. And then I just used the area formula for the triangle, which is 1/2 base times height, which would be 1/2 times 6 times 2, which would be 6.
Oh yeah, we were both good. If I had just not made it. Sorry, some of your lines and everything. Are we okay? Why was it so nice and easy, and why did my way work as long as I made the 3 into a 2? My function was in terms of? My bounds were in terms of? And what was my between? It was between this guy and who is my secondary function? So if I'm doing an f and a g, that's my f. What's my g? Well, isn't this x equals 0? So if I wanted to show you my f minus my g, it'd be 3y minus 0. Oh yeah, no big deal. Absolute value, it's all positive anyway. I was good. I was solid. Nice. But will it always be that easy? Automatically, right away. What do you see as soon as you start reading the givens in the second example? X's and X's and more X's? Really hope it's a dx. Ready, set? It's up to you. Do you want to do a picture? Or do you want to just plug it in blindly to a formula and hope that you're right? But not everybody's brain thinks like that. Ready, set, pick away and go. Yes, bye. This one's not too bad. There's no trig and weird pi sign. Can we pause in the calculus for a bit? Because I'm assuming most of you are inside an integral or the solution thereof by now. I haven't done any calculus yet. I'm just curious. What was I doing over here? Why was I doing a quadratic formula? Why was I finding the zeros? What was I actually doing? To see if 0 to 1 are the natural bounds. To see if there are intersections. Why? My quick algebra people. Let's go! What did you not technically think about if you just like wrote that in one? You didn't think about Why is the absolute value there? In case there's an orientation shift to where this subtraction is saying you're on top and you're on bottom, right? The absolute value says, okay, maybe he's the top and maybe he's the bottom, but the checking for intersection says, what if he's sometimes the top and him sometimes the top? So what was I doing? Making sure there was no intersection. Is there an intersection? No. Quadratic formula says, I didn't want to do intersection, I wanted to do factoring. No intersections, but what did the graphs also say? No intersections. Either way, do I need to worry about splitting up anywhere? No. So would you have been lucky and okay if you didn't even consider the fact that maybe there was an orientation shift? Yeah. Zero is just going to be 0, 0, 0, right? Any stupid mistakes that I made? Not this time. Okay, good. Why am I not worrying about the absolute values? Because it's always positive. There's no intersections, and I know who the top is, I know who the bottom is, and I happen to do it the right way, but would it be safe to throw those in just to make sure? And I have 1/3 plus 2, which is going to be 7/3. Plus 1/2? Aw, you got to be kidding me. Why am I doing this? And let's just say it was a multiple choice question. Don't we need to go to 6? So we have 3, 6, and we have 14, 6, and so 3 and 14. Ooh, not 16. Man, I'm making a silly mistake today. Did you guys beat me? Do you concur? Any questions on the process, though? Why was it an easier than AP problem? What might they do? Bring this guy down. Bring this guy down and have the bounds be maybe something like -5 to 0. So then if you bring him down, sometimes the parabola is over the line and sometimes the line would be over the parabola. Mean. But it's okay because the math would have found some intersections and maybe I would have split the bounds. No big deal. Nothing to stress about, right? So what if they don't give you bounds? Look at you guys, spoiled rotten. Other years this was probably covered up. Okay, you see it's a parabola, you see it's a line, but I'm taking away the graph. Go. There you have 15. If you finish this early, you can ponder, can these exact same directions have been given to the functions in the problem before, with no defined boundaries? This one just says, find the area bounded by. Would they have been legal directions for the problem before? Let's try to solve this one first. Algebraic people, you plugging and chugging and hoping that you're good? Keeping an eye open just in case you're not. Getting stuck because you don't know what to make your bounds? Oh, you gotta slow down a little bit. Anybody factoring? Or already factored? What are your bounds, school kids? Do I need to worry about splitting out? Where would I split it up if I was to split it up? At orientation wrong, so alright. Your absolute values are on the whole thing. If it's a negative, I just did the wrong top, the wrong bottom, but otherwise, no stress. Except, stupid mistake. I might have heard you wrong. Or I might have read that wrong. Either way, proper bounds are -2, right? But pause. Did I actually need those absolute values? By graphing people, it's your turn. No, because of course that parabola is on top. It's just a downwards facing parabola. It's just F2 and the line's down there. Oh, no big deal. Top, bottom. I don't need to worry about it. I'm good. Non-visual people, whatever. Go for it. And then if it's positive, keep it the same. If it's negative, oops, I made a mistake. Yeah, I just oriented it. For those absolute values, even though I totally know that I'm fine, so there was no need for those, they're redundant. That's okay. I don't like putting stuff together if I don't have to. I'm going to go ahead and do 4 and 2 is 6, and 6 and 2 is 8. And I have a -1/3 and a -8/3. That's -9/3. That's -3. And then I have a -1/2. That's a lot easier than changing everything to 6. So I have 5 minus a half is. I guess we could have done 9. Hold on, double check me. Did I do anything dumb? I'm trying to talk and write at the same time. What happens? Give me a thumbs up if you're like, yeah, we're good.
Why is the negative, like, when you did FTC, it's like, so 2 minus 1/3 minus 1/2? Is that a minus or plus?
Oh, it's a minus that I distributed, and when I distributed, I made it a plus. So it's FTC, F of B minus. And then I said, hey, let's distribute my negative. So negative times a negative is a positive, negative times a positive is a negative. So I just brought it in.
So you wouldn't do absolute values like within?
And that's the common mistake. Absolute values inside an integral, I need to consider whether or not intersections are necessary and split up. And then the absolute value goes outside the integral, which means outside the entire FTC. So PEMDAS, all of the inside needs to be done first with a proper F of B minus F of A. Then the absolute value is applied to the final result. So there's no switching of anything until I have a final positive number that doesn't need to be switched. So I'm good. Dangerous if you go playing around with any signs before that. Good, good, good? Well, how much worse can it get? Sorry, that's making me weird because there's like 2 different lines and it's throwing me off. Maybe it's not a big deal, but there we go. That's nice. Ready, set, have fun? More involved? Ah, this doesn't look bad. No big deal. Where's that go? Green pen trick. Maybe you don't remember that guy. You tutored a calculus AB kid recently. You should remember the green pen trick. Especially when finding critical numbers of something gross like this. Green pen trick is necessary for that dude. Maybe necessary for this dude. It's not a calculus technique, it's just a simplifying technique. With a silly, I decided to use my green pen, so I just made it a thing. Try to make it memorable. unless you really want to go ahead and do like Pascal's triangle 1, 3, 3, 1, and then actually, I mean, you could. Or you could just say, hey, U sub, it's not a big deal. As Kevin just said, get that entire FTC before thinking about whether positive or negative. Some of you more visual people, you might have thought about symmetry and whether or not these two pieces would be the exact same, and if you found one, you could just double it to get the other. That'd be nice. If there's a distance of 1 and a distance of 1, and there's a symmetry about 1, that could be kind of nice. This would be the exact same thing, just evaluated. Is it 1 minus 1, 0, 1 minus 1, 0? 0 minus 1 is a, 1/4. And then minus 1/2. Yeah.
Do you like the property of like you can cross out the ones and make it into really 2?
You could, except you'd have to bring that absolute value inside, because absolute value has to be split up at all intersections. Does that make sense? Is that going to be a negative number? Yes. Is it going to turn to be a positive 1/4? Yeah, it is. 1/4. Do the subtraction first and make it a positive 1/4. This guy, if I plug in 1, that's going to be zeros again. But that 2 minus 1 is a, it's 1/4 and 1/2. Ha! Hey, look, it's the same thing. Except this time. Hold on. Minus FTC. Technically, that was a negative and a plus. Sorry, I didn't do my F of B minus F of A. That was dangerous. So this one is F of B minus F of A. That's proper. What's the end of being? Double check me in your calculators, but I believe. Wait, how would you do this in your calculators? Kevin, didn't you just say you could have condensed it? And Lorenzo, what are you telling me? Put an absolute value on the inside. If you could do it in your calculators, you could have just done it this way. Now, did I say it was a calculator problem?
No.
But if it was a calculator problem, ta-da! Dun, 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 dun. Bye guys, have fun. That was the end of note section 8.2. Area, due tomorrow. You know why. It's review. My algebra people, plug into formulas. Hope you're right. Double check you're right. See you later.
Crystal Palace is tied.